Hi, so I'm Manfred Arndt. I'm from HP Networking. I'm our Chief Technologist for UC&C, and I'm part of our Advanced Technology Group. And the Advanced Technology Group is our CTO office driving future direction around HP Networking and Pan-HP, and also been very active in standards. I'm on the UCIF board. I'm driving SDN activities in there. I'm part of the Wi-Fi Alliance focused on mobile multimedia, how to fix the sticky client problem. I've also involved in 802.11. I've been involved in 802.1 and .3 around things like LLDP and LLDP Med to optimize IP phones, automate things, improve network management. And I've been working with Lync, or prior to what it was Lync, OCS since 2008. And I'm kind of the key technologist focused on our strategy of what HP Networking products are doing with Microsoft. And I think Lync's been a fantastic solution. So the agenda is, I'm going to talk about some of the UC&C challenges, because as applications are moving into the cloud, the PBX is dead, long dead, and Lync is really kind of at the forefront between Lync and Skype, changing it from a appliance-driven model into truly a software application-driven model, what it should be. But as part of that, the network is becoming critical, and I'll touch on that. I'm going to touch on the SDN API, how the application can now direct the network, the difference between guessing versus knowing. I'll talk about Lync network requirements, and I'll talk about some of the solutions we're working on, some pretty exciting stuff we're doing to really transform how networks are provisioned for real-time multimedia. And then talk about next steps on how you might do SDN, because I don't expect anybody to do SDN or software-defined networking overnight. So today's UC&C challenge, in the first bullet, this came from Microsoft. And this is very much in line with what I've seen with other solutions as well. But network issues are responsible for around 60 to 80% of audio quality issues, or QoE, or poor user experience. There's nothing wrong with the application. It's how the network is provisioned. And the problem is what's happening is, I'll go a little bit more detail later on why it works in the IP phone world and why there hasn't been a problem in the past. But it's surprising as people start going in the software world, they're starting to have problems with things that they never had problems with in the past. And the root of the problem really is Lync uses encryption by default. The same device is doing voice, video, data, other applications. And users can put anything they want on their laptops. So it really becomes hard for the network to figure out what the application is doing. And then newer applications like Skype intentionally try to hide themselves from the network. So that makes application recognition really difficult or nearly impossible. So things that the network used to do, like deep packet inspection, simply is broken and doesn't work anymore. We need a new model. The other part is traffic engineering QoS is really complex and hard. But when you get things wrong, it's even harder to figure out when it went wrong. It's like finding a needle in a haystack. Because on a good day, you think you've got it set up correctly, but you have no visibility that it's working or not working. You have to wait till there's network congestion. And so you think it's okay, and then you tend to have very intermittent problems. And these intermittent problems are really difficult to find. So this is really about how do you make the quality of experience automated and simplified, and when things go wrong, how do you diagnose it in a much easier manner? So from a network standpoint, let me highlight a couple points from the architecture of where problems are likely to occur. And the first really is at the access layer. So down here at the access layer is, let me go to the next part here. It's really the user access. You want to figure out what is the application doing, and can I trust the application, or can I conditionally trust it, or is it a guest user I can't necessarily even trust at all? So this is where you want to do the application awareness. You want to identify that QoS at the beginning of your network, because QoS is only as good as the weakest link. So you want to do it as end-to-end if possible. And then the other area where you've got problems is at your end of your domain. So at the end of the enterprise domain to the service provider, or between different parts of your organization, because you might have acquired another company and you might have slightly different policies from site to site. So there's a couple domains in it. But inside your network, inside your core network, there really is rarely ever a problem. With the IP phone, things have worked for a very long time. And the reason is when you plug the phone in via LLDP Med, it auto-configures itself to the voice VLAN. It gets its QoS policy. The phone marks both a layer 2 801p priority, and it marks the layer 3 DSCP priority as well, and you can trust the device, and it's not doing anything other than voice. So that model has worked really well, and having core policies configured, many enterprises have got that correct, but it's that at the access layer, how do I recognize a soft phone, what they're doing? And on top of that, most OSs, even Windows by default, doesn't turn on QoS, so you have to go on, make sure you enable it, and then you might have to go into the group policy to make sure it's configured right. But we find in a lot of organizations, IT managers don't want to trust the endpoint. And the reason is you as a user, if you realize that, hey, if I just remark my application, if I remark my World of Warcraft, if I remark my BitTorrent to run at a higher priority, and the network just honors it, I get better service. And I liken that to the carpool lane. You constantly see people getting busted for putting these dummies in the passenger seat so that they can bypass the rules. So users, invariably, if you let them get away with things, they will do it to get away with things. So what our vision is, and I'm working closely with Microsoft on this, is to make the applications and networks play better together. Okay? The difference between guessing and knowing. So I'm going to talk about application-directed software-defined networking and how voice and video plays a big demand on networking. So let me kind of touch on what Gartner's view is on software-defined networking. And then I'll drill into a little bit on what SDN means. And the thing with SDN, there's a lot of people that have different ideas with SDN. It's a really hot topic. Almost a day doesn't go by between hearing dozens or hundreds of articles and blogs about SDN. So I want to kind of dispel what is SDN, what isn't SDN. But Gartner's view on SDN, this is very much like an example I like to make, is you're driving through a busy street. Let's say you're in Las Vegas on the main strip, or you're in Boston and you're late to work. The traffic lights always seem to change. The bigger time, you got an important meeting coming up. So the later you are to that meeting, the more these lights just happen to love to change as you're pulling up at the most inopportune time. And these lights are independently. So while they do good functions, just like networking switches do good function, if they're not synchronized or orchestrated, how can you get packets through the network end to end? So their view is each router, each switch is making its own inspection decision, and there's really no coordination of this. And on top of that, the way people are configuring them today is via cryptic CLI, command line basis, and it's very easy to get things wrong. Instead, SDN is really more a centralized solution where you've taken the policy decision out of the individual boxes and you more centralize it, and it allows you now to orchestrate things across and optimize things. Just like in a Google map, if there's a traffic accident somewhere, it knows that and can reroute traffic around there, so making more of a global decision than a locally sub-optimized decision. So what I'd like to do is highlight what's different between application-aware networking and application-directed networking. In the past, the network infrastructure really tried to do deep packet inspection, try to apply heuristic, and try to go, this looks like voice. This looks like video. I think this is video. Okay? But you're still guessing. You really don't know. It's easy to hijack. If you know what port numbers, say call manager application might be running ports 8000 through 8080, if the user knows that, they can start using those port numbers and getting a better quality of service. Or they can mimic the behavior of that application. So it's not very trusted. It's not a very trusted model. Or in some cases, some networks simply just honor the layer 2 or layer 3 QoS marking, so it's very easy for somebody to hijack that model. Application-directed networking, on the other hand, is you're truly aware of what the application is doing. You're aware of what the user is. You're aware of how much bandwidth they need. You know administrative policies, some very high-level policies, what you want to do with that, and now you can make some much more intelligent decisions that are optimized across the entire infrastructure. So when you hear SDN, there's a lot of people that try to jump on the bandwagon of SDN, but a couple things that SDN isn't. SDN isn't about just a software solution, say a software hypervisor or a software switch. That's not SDN. Okay? SDN isn't about scripting. So if somebody says, oh yeah, on our switches we've got these Perl scripts and we can script things and automate things. No, that's not SDN. Some people say SDN is about network management. No, that's an important component of SDN, but that's also not SDN. SDN is taking some of the intelligence out of the endpoints and using it to make dynamic policy decisions on a per packet or per flow basis. If I use a network management platform to provision something and it sits there continuously, that's not really SDN. It's an important component, but not SDN. So as SDN, what we've done is we have the hardware switches at the bottom here. These are the network elements, so switches and routers. And OpenFlow right now is kind of the leading protocol. There may be others, but OpenFlow is a standard mechanism now that a controller, so SDN controller can use to provision and program the network elements in a consistent manner and provide policies to that. And we call that the southbound API. The controller is now kind of orchestrating what the network elements does, but it's still at a fairly low level. And I'll go into more detail on a subsequent slide on that. But it does things like topology. It knows things like link capacity. It knows things like where devices are. It knows what traffic is running on there. But it doesn't really know high-level policies. That's where we need a northbound API that allows us to expose business logic, things like load balancing, things like QoS. And so the northbound API, we'll often refer to NB API. You'll hear that term. And that allows us to really transform and automate and program what the network is about. So as part of the, we've got a POC, and I'll give you a little demo of the proof of concept that we've done. And this got such strong response that we're now productizing it. And, but in addition to that, we didn't want to just have a proprietary solution where we did something with Microsoft. We believe this is really applicable to a large class of applications. And as such, we feel it's very important to standardize that. So HP and Microsoft were taking a lot of leadership position. So inside of the ONF, what we're doing is driving the standardization of that northbound API. So together with Microsoft and some other industry partners, we started a new work group. And this work group is about the NB API. HP, one of my peers in the Advanced Technology Group, is chairing that. Pascal, my counterpart at Microsoft, he's working on the user work group. So he's the vice chair of the user work group, and that's focused on the campus and branch use case. So trying to identify use cases and data models on how to apply SDN in the campus and branch. Another one of my colleagues that used to work at Plexi, now HP hired him, he's focused on the data center use cases. And we believe there's a lot of commonality, but we want to make sure that we focus on the right use cases for those applications and are working to drive that forward. And in addition to that, we're heavily involved with OpenFlow. HP started working with OpenFlow before it was called OpenFlow. We started working with Stanford University in 2007 when it was called Ethane. We thought it was a pretty cool technology. We didn't quite know what we could do with it, but we wanted to work with the research community to see what kind of things we could do with that. And we were kind of, even ourselves, taken aback at how quickly that got adopted, especially when Google started using SD inside their data centers to dynamically route traffic. And when other companies got wind of that, they're like, wow, this isn't vaporware, this isn't, leading technology. People are actually using that to radically transform how they're operating their network. And because of that, because we had been working with these universities for a while, we had put hooks into our ASICs, into our switches, that allowed us to expose this functionality in our products well before the competition is. And that's important from a standpoint of how do you get a phased migration. I'll drill into that a little bit more into detail. But before that, I'd like to go into a little more detail to have you understand how does OpenFlow and how does a switch behave in what it's doing. Because in a switch, you have two key components. One is the control plane. And this control plane does things like routing protocols. It does things like spanning tree. It's the logic behind it. And then you've got the data plane. The data plane is done in ASICs because you need to be able to support gigabit, 10 gigabit, 100 gigabit line rates. That's where the ASIC is performing its magic. So in a true SDN model, what we've done is we've pulled the control plane out in the controller. The reality is it's going to be a little bit of hybrid. I don't believe in idealistic solutions. What's going to happen is you're going to have up here, you're going to have a significant part of the control plane both in the switch and in the controller to allow you to run in a hybrid model and migrate over time into that solution. But in the control plane, you've got something called these flow tables. And what the flow table allows you to do, and this is similar to how switches have always worked, they've got a flow table that allows you to match on things like IP address, MAC address, port numbers, some detailed information in there, and then it can have rules. But OpenFlow extended that and added more capabilities. And the other thing it did is we'll have a need for deeper and larger tables, because when humans have to program, there's only so much humans are willing to do. But when we automate it, we're able to do much more per flow processing. So when people say it's going to be commodity switches, no, I don't quite agree that it's going to be commodity switches. It'll make the cost of managing your network more cost effective. It'll improve the standardization between solutions. But I think what SDN is really going to do is allow you to expose capability that's been inside the hardware that people never really took advantage of because it was so hard to program that aspect. So the kind of actions that we can do is when an OpenFlow policy comes down, these are kind of primitives. We can do things like forward this packet out of this port. We can do other actions like modify this packet. So for the QoS standpoint, that's what we're using. We're going to say modify the layer 3 field in the IP header, change the DSCP code point to what we trust. Other actions we can do is we can encapsulate it. So an example of something really powerful there is I might want to do a remote mirroring. Okay, if I've identified where my audio quality experience problem is happening on which two endpoints, rather than putting a probe out there, rather than carrying or having a user in that branch go out there with a protocol analyzer to take those packet captures, you can now, via SDN, instantiate a command that says, mirror that, copy that packet for only that flow, and encapsulate that and send it to me, and then I can do remote packet capture. When we mention that to people, they go, wow, that's pretty powerful. After my last session, somebody came up to me, could I do call recording with that? Right? Is call recording you want to mirror the packets? And that's always been a really, really difficult problem. And the question is, do you record all the traffic? Do you want to selectively record the traffic? So there's a compelling use case of how in a UC or telephony environment you want to mirror selective traffic. You don't want to mirror everything because you're going to get overwhelmed with it. You can mirror a very detailed flow and only that traffic. So now let me go up the stack a little bit and show how that model interacts. So before I was kind of showing the piece down here at the bottom. That's how the OpenFlow piece works. What we have is we've got the SDN controller. And that's this piece here, that middle layer, which we call the network control and management piece. And in that layer, we've got things like what I highlighted, topology. The controller knows things about topology. It knows things like inventory. It knows things like flow program, but still pretty low-level primitive. We don't want applications like Lync or other applications to program to that detail because they're likely going to make mistakes. They're probably going to make more problems than it'll help. So what we need is we need a network services function, which is kind of that layer above it, and there can be a variety of different services. One service could be security. There could be a service for load balancing. There could be a service for policy-based routing. The part that we've been innovating with and demonstrating here, and one that we believe is one of the most compelling use cases to get started in a way that's hybrid and not disruptive, is this automating of QoS. And by doing this, we'll have things like a QoS policy manager, and that allows now an application like Lync via the northbound API to interact via very high-level policies to provide us the intelligence of what we need to do. And we're not taking the human being out of the picture. The human being will still, the network administrator will still be involved with deciding what type of policies I want to have, but they can do it at the high level. They're now not doing low-level, machine-level programming that I don't think any human being should be doing. If anybody's ever tried to write ACLs for Cisco CLI or iOS, it's not fun. And I'll explain in a later slide why that often goes wrong, because there's a human middleware between the server guy providing the information, add these port numbers to your switch, and all it takes is you to get that direction backwards to get a couple numbers transposed. And I've spent a couple days debugging a customer network where only on one switch that was misconfigured. Any questions on that? Okay. So in this model here, this is kind of our proof of concept of what we've done with Lync. We've got the controller in the middle, program the switches. We've got a UC&C network services application, and we've got a northbound API that Microsoft released last fall, and they've just released the 2.0 version based on learnings of what we've done on real-world testings. And the benefit really is simplified policy deployment, dynamic prioritization, and enhanced user experience. And we're doing this in a hybrid model because the reality is while SDN is very compelling, and we've seen people in the data center do greenfield deployments and running pure SDN environments, the reality is people are not going to do that in the campus and branch. When's the last time you've seen a greenfield deployment? I mean, that's very rare. So how do we get this exciting technology out there? And the way we're focusing on it is open flow, depending on the vendor, but in our solutions, we allow you to run in a hybrid model. So we can enable it on certain ports and only on certain VLANs. So this allows you to apply the SDN at the access layer only, and I'll drill more into detail in a subsequent slide how that works. That allows us now to provide it, why redo the whole network functioning that's already working? The routing protocol's already working pretty well. Things like spanning tree have issues, but it's working for the most part. So why break that? To get people adopted, we want them to say, what are you having a hard time on your network with? Things like QoS is really hard. Network access control is really hard. Network diagnostics is really hard. Security is really hard. So those are the functionalities we're driving to allow customers in a hybrid model to automate and distribute functionality that sometimes we did in a core box and do it at the access layer. So this is one example of it. Here's another example of what we've done is we have a Sentinel security application, and what we're doing is, I don't know if you all heard about IDS, IPS, but intrusion detection systems, intrusion prevention systems. Very important boxes that many enterprises deploy, but today they're appliances. They're, either a gig box or maybe a 10 gig box. They're very expensive appliances. You typically put in your data center, so only the traffic that actually routes through it will be inspected. But sometimes you don't even want to run things like UC traffic through there because it can impact the audio quality experience. So how do you scale that to solution, especially as enterprises now are starting to do split tunnels or redirect traffic out of the branch site without going to the central site? How do you protect your network? Well, with this type of approach, we can provide maybe not the 100% of the functionality, but we can provide a subset of that functionality on every switch port in a very cost-effective manner, but leverage that same remediation database. So in this model, what we're doing is a new flow starts. We redirect it to the controller, and the controller now looks at this tipping point remediation database, and there's over 700,000 known threats that in there, and it compares that in there. Is that user trying to access a bad site, a site we know has malware or is infected? And we do that both on DNS and on IP, because somebody might know the IP directly, or they might have updated the host table. So this allows us to inspect a new flow. And once that flow has been inspected, we program via OpenFlow a rule in there that says, okay, future packets for that flow are trusted. And now we've only impacted the very first packet. And then subsequent packets run at full line rate through the solution, as opposed to in the IDS, IPS, every packet goes through the choke point and impacts it. And in here, for example, you can now start applying analytics to it and saying, I've got a port where a large number of new flows is appearing, something weird's happening. You could now actually mirror that traffic back to central IDS, IPS, and do more detailed inspection on that port or a subset of that traffic. But you can't mirror all the traffic from all ports to an IPS. That's simply not possible. So it's really kind of showing you how we can transform some of the things that were done in networking, that were done in dedicated appliance. We can now distribute that throughout the network in a more scalable manner. Let me now step back and give you a little bit of overview of SDN a little bit. I want to kind of talk a little bit more about some of the network requirements for enterprise voice, just to highlight and reiterate why network, real-time traffic for voice and video is different than other data traffic. It's got very strict requirements for, you want to ensure that there's no packet loss, you want to ensure good latency, and we'll show how this solution helps address that. The difference between typical data applications is really a kind of a more of a bulk service. How do I get this data from point A to point B as fast as possible? So TCP stacks are optimized to take up whatever link capacity they're able to take up. So they'll burst that traffic. and that impacts the audio quality experience of real-time traffic because the switches themselves only have a finite size of queues and buffer spaces in the switch. So I liken that, say you're going to Disney World, and let's say there's only one line. And it's, on maybe an average day, there's not much of a line, but in the morning at 8 o'clock, a little bit of a line shows up, and everybody has to wait the same amount of time in this long line. But what gets worse is the switch only can handle the line so long, so if the line gets past a certain point, imagine them saying, sorry, you got to go home now. You got to start your whole trip over again. So instead, what we're doing is we have multiple queues, and what we do is we want to identify which traffic needs preferential treatment and queue them separately so that we ensure that there's no packet loss for real-time traffic. So voice, while it's not a high bandwidth application, takes up 100 kilobits uncompressed. And over the WAN, typically compressing it is a good idea. It takes 30 kilobits, but it has very strict quality service requirements. Now, one thing that Lync has done, some of these newer advanced codecs do things like packet loss concealment. They do things like FEC, which mitigate the impact of poor networks. And I liken that to, say, a four-wheel drive vehicle. Okay? That's a good step. And so we need to have applications do better things. We need to have networks do better things. We don't need to over-engineer things. QoS shouldn't be too complicated. QoS should be kind of like your carpooling on the freeway. And the codec should be like your four-wheel drive vehicle. There are some places where the highways just don't go, and that's when the four-wheel drive makes sense. But nobody's going to take their four-wheel drive off-road when there's a freeway nearby. Your experience is not quite that good. Same thing with Lync. When your Lync runs pretty good over the internet, but you're going to have inconsistent experience. You might only get it good quality maybe 80, 90% of the time, but on a busy day, you may have problems. Likewise, if you're trying to run over a WAN link and there's a lot of data traffic on there, you're going to have a performance bottleneck. Same thing with wireless. So it is important to have an end-to-end QoS experience. So when you're transitioning from that PBX, people are going to get that call quality and consistent experience they're used to. Because once they have a couple problems on it, they're going to badmouth the solution, and that's going to impact your adoption. So let me kind of talk about some of the different types of QoS classification options. Because there's a couple different ways the networking will classify traffic. The old school way, which we started doing when IP phones first came out, was we basically said, let's put the phones on a separate VLAN, and we're going to treat all that traffic as a higher priority. That works fine for IP phones, just it simply won't work for UC. It simply won't work for Lync because that doesn't support soft phones, and so how do you prioritize voice and video differently? So that option, don't even do that anymore. It's old school. The other one is layer 2. So in the bottom here, you'll see I've got an overview of what an IP packet looks like. At the beginning, you've got the Ethernet header. You've got the VLAN header in here. Inside that VLAN header is the priority. Then you've got the IP header. Inside there, you have the layer 3 priority. Well, the VLAN priority only exists on tagged links. Okay? It doesn't transition from source all the way through the network to the very end of the network. Soft phones or PCs will not use a VLAN tag. So if you try to use layer 2 priority, you're typically going to have problems because you think you've configured the QoS, but in the reality, you're not sure what you're doing because it's regenerated on every hop. And on a WAN router link, there typically is no VLAN header either, so it's stripped off. And worse, if you're trying to troubleshoot it, let's say you're pulling out EtherReal and trying to debug it, you might not get the header from your NIC card. So it depends on your PC. So troubleshooting becomes very hard. It's not end-to-end. So my recommendation is only use layer 2 as a last resort if the switches don't support layer 3 priority. Okay. Most switches, even if they're a layer 2 switch, can support layer 3 priority in QoS, layer 3 ACLs. That doesn't mean you've enabled routing. Okay. You can enable, it's kind of a mixed function. It's doing layer 2 switching, but you can apply some layer 3 policies, and it's fairly straightforward to do that. On HP networking switches, it's one command to enable that. So, IP QoS type of service is diffserv. It's one command, and then we've defaulted the common code points so that the core policies are pretty straightforward. The problem is how to recognize the application and get it in there. Okay. So layer 3 is what I recommend doing for Lync, and that's what you can start doing today if you're not SDN ready. Okay. I recommend doing layer 3 QoS priority end-to-end because it's the most consistent mechanism for you to see what's going on. It's the easiest to troubleshoot, and it's fairly straightforward to configure on modern enterprise-grade equipment. The advanced mechanism is what we see larger enterprises using. This is what I see customers using that aren't trusting of the endpoints and the end users. And this is when they actually apply access control lists, or ACLs, typically in the access layer switch and maybe WAN routers, so they can reprioritize traffic. But herein lies the problem. Lync by default encrypts, and Lync by default uses ports 1000 through 65535. So if you're aware of what that means pretty much the entire port range. And then I've got a subsequent slide that kind of drills into that challenge a little bit more. But to me, that is not something human beings should be programming. This is where I think computers and controllers are well designed to take that intelligence and apply it automatically in a manner that just happens to work. So the hardest part is actually identifying what the application is. Once we've identified that application, as an industry, we've done a pretty good job knowing how to treat it. Okay? So this is what you typically do in your core of your network. You have to have a guidance that says, what do I want to do with voice? What do I want to do with video? There's not a right or wrong answer, but this is kind of where ITF has kind of recommended. This is what HP Network recommends, and this is very closely aligned with Lync does. The one exception, file sharing between Lync is slightly different. We're recommending a CS2. They're recommending, I think, an AF2 or AF21. So it's very similar. But the important thing is voice typically needs to be your highest priority. Expedited forwarding is what the industry's agreed on. Video should be AF41. High bandwidth should be below voice, but it needs to be a high priority. And then the signaling traffic is good to put in a separate priority too. But if you mix the signaling with the voice, not that big of a deal. But you don't want to run signaling at your default priority. You want to make sure that when phones ring, they ring timely, or when people ring somebody, it's in a timely manner. And even things like desktop sharing. It's running TCP, and most people have been kind of conditioned. You don't need QoS for TCP. TCP retransmits. Okay? I'll show you in our demo an example how that's why in a lot of times you see a sluggish user experience. Okay? When a TCP packet gets dropped, it gets retransmitted, but that turns into latency and a slower responsiveness. Okay? In a UDP situation, it results in a packet loss, results in a pixelation of the picture, audio dropout, in a really annoying conversation. But in a TCP session, it results in a delay. Like, let's say you're watching a YouTube video and you get that buffering. That's because you've gotten some packet loss or congestion on your network. And so I want to highlight, for video, there's multiple types of video. Real-time video, like desktop video between Lync, Polycom video is real-time video, needs a higher priority. Streaming video that's TCP-based doesn't need that same level of QoS and shouldn't be mixed with UDP traffic. You should segregate UDP and TCP traffic into different priority queues. Okay. So let me drill into the demo that we've done, the proof of concept, and this is what we have been.
The UCNC SDN application automates network policy in a dynamic fashion, unlocking the full potential of unified communications and collaboration solutions through an enhanced user experience. Take, for example, two employees attempting to collaborate via Lync using application sharing. On the top left, we have the user James, and on the bottom left, we have the user Linda. James initiates a call to Linda and then starts sharing an application. As you can see, Linda's user experience is significantly delayed and not synchronized with what James is sharing. This is not a problem with Lync, but rather an issue with how the Lync traffic is handled across the network. This poor user experience is all too common with today's UCNC solutions. In fact, users are not only frustrated by this, they have come to expect this type of experience as the norm. The reality is that poor application performance is a drain on productivity and limits the power of unified communications and collaboration solutions. On the right-hand side of the screen, we have the HP UCNC application in a disabled state. When we enable the application, the user experience is instantly transformed. Now both users are seeing virtually the same information at the same time. The UCNC SDN application has taken call intelligence from the Lync server and used it to implement OpenFlow rules via the HP Virtual Application Network's SDN controller.
So when we started doing this demo and taking them to different trade shows, we got such a fantastic response from customers, service providers, from integrators, resellers, that we're now productizing the solution. And let me drill in a little bit more to explain exactly what's going on underneath the hood and how we see this working kind of in a hybrid model. But the response has been really fantastic. And what's exciting now is in the SDN model how much more innovation we can get into the network. In the past, anytime we wanted to add a new routing protocol, add a new switching protocol, it would take years to get that developed in the firmware, because embedded firmware development is very difficult. These switches never have enough memory because of cost reasons. We've limited the amount of memory. The CPUs tend to be underpowered CPU. So adding new functionality is really difficult. So we might add it to the newer switches, but not the older models. Well, then it takes years to get that new hardware into customer networks, because the lifespan of these switches is 3 to 7 to 5 to 10 years that people expect these switches out there. So how do we add new functionality and expect customers to deploy that over the years? What we find exciting now is I've seen more innovation in the last year than I've seen in the last 15 years of my life. And when I go to these customer seminars and I'm talking, rather than me pitching ideas, I start talking for 5, 10 minutes. They start telling me, oh, what about call admission control? What about dynamic routing? Can it do that? What about call recording? Can we start doing these kind of things? And it's exciting that once we build these primitives with this OpenFlow capability into these switches and start building this infrastructure of SDN enabled, we can start creating an app ecosystem of partners building innovative solutions. Just like one of the strong benefits that Lync has some tremendous APIs that allows contact center partners to add additional functionality. Right? That's a really compelling part. Do you have a question? Do you want to come up to the mic, please? So like I said, so we see this really enabling an ecosystem of much more rapid innovation and abilities of what we can do to automate it, and then also to diagnose and troubleshoot the network.
So Manfred, I got a trick question for you. So let's assume as a customer I want the orange, the HP, but you're HP, right?
Yes.
But I really like that. How dependent am I on your SDN controller, I presume server, and your OpenFlow switch?
Great question. Let me defer your question for a little bit, and let me talk about how this works, and then I'll explain exactly that, because we feel it's important. We don't expect somebody to have all HP products. People are excited about this, but they say, how do I deploy it in a mixed environment, and how do I deploy it in a partial SDN environment? So when user James is contacting user Linda, the signaling and media will flow different paths. Okay, so both are encrypted, but the Lync server knows exactly what's going on. It knows the user's name. It knows they're doing voice video data. It knows how much bandwidth they're trying to use. It knows things like IP address. So the Lync server knows all the virtual information. Okay, doesn't know anything about the physical topology or hardware or things in between it. The SDN controller, on the other hand, knows all the physical information. It knows what switches there are. It knows the topology. It knows the link capacities. It just doesn't know the application. By bringing the two together with this API, the SDN application knows now who the users are, what they're doing, and now can apply that dynamic policy on a per-call basis only on that flow. So by default, the access switches have no policies other than who my controller is. You need to point the switches to the SDN controller, and that's the only policy you have to have on that switch, and you have to enable the hybrid mode SDN. Now what we can do is program that OpenFlow rule only for that flow, and any other traffic. So in our demo, we're running a traffic generator that's configured with EF marking. The switch simply ignores that and remarks it back down to best effort traffic. Or we could even mark it as lower than best effort traffic. Okay? And so the part of the highlight is even if you've got other vendor switches in the core, you've got other vendors WAN routers out there, we can now apply that in a mixed environment. The only requirement is you have to have OpenFlow enabled switches that support a hybrid mode to support this here, and you need our SDN controller for this solution here. Our first release, we're only going to support HP switches on there because we want to make sure we test it and get something out there. But in a subsequent release, we are going to start supporting some third-party switches as well. But there is a little bit of a challenge with that. There's not a lot of other third-party switches out there right now. Most of the SDN vendors are focused on the data center. That's where the majority of innovation has been. We believe SDN is compelling from the application in the data center, through the core of the network, through the service provider network, to the campus and branch where the users reside. So really the benefit is it's kind of a slicing of the traffic and treating a virtual circuit, but not just a virtual, but also one with bandwidth guarantees and QoS policies in there. And so for the first release, we're going to support only HP networking. And like I said, the limitation is outside the campus. There aren't a lot of other vendors that have OpenFlow today, or if they support OpenFlow, they might not support the right revision of OpenFlow. We're up to OpenFlow 1.3 in our products. OpenFlow 1.4 is being standardized, but we will support other switches as well. Part of what we're doing is the API between a controller and a switches is OpenFlow. So we believe it's very important that you work with vendors that are not working on proprietary protocols. Some vendors want to open source their controller and then use one PK to configure the switches because, hey, you can have the controller for free, but the catch is you have to buy all our hardware. That's not very open. They claim they're open because, oh, we're open to the applications, but as long as you're willing to buy network hardware from a single vendor, completely end-to-end, it's not a very open platform. So we believe as long as you're using OpenFlow down here, this type of solution could work with another controller. We'd prefer you buy our controller, but we know the reality. There's going to be other controllers out there, and there's going to be networks that might want to have more than one controller. One controller might do QoS, another controller might do diagnostics. So we will support multiple controllers managing the network. We will just make sure they're not conflicting on the same resources. Then the part we're standardizing as well is a northbound API between the applications because we believe this is compelling not just for Lync traffic, but there's a lot of other classes of traffic that are real-time and interactive in nature where you want a very good user response. Like VDI, for example, or thin clients. When the user moves that mouse, it doesn't appear like a video application, but in reality, it really is more like a video. When you move that mouse, you expect that screen to update and refresh immediately. And users are becoming impatient. They no longer are willing to wait half a second for things to do. You're getting more and more impatient as time moves on. Did that answer your question? So let me kind of drill down another level further to show kind of how this would work in a hybrid, in a real topology, because one of the common questions I get is, well, great, I get how you're marking QoS at the access layer, but isn't my WAN my biggest performance bottleneck, and how will that work in the model? And WAN routers aren't SDN enabled today. We've announced that our WAN routers will be SDN enabled, and we believe there's some compelling things you can do when you have SDN enabled WAN routers by themselves or just access layer switches, but when they're together we can even do more functionality. So each alone is compelling, but together we can do even more. But the reality is it's going to be a while before maybe people are running SDN enabled WAN routers. But in here what you can see, when early media starts, because the early media will actually kick in at times before the signaling is all complete, it's running best effort, or who knows how it's marked. But let's assume QoS was not enabled on the endpoint, so now it's running best effort. The dialog event from the northbound API comes in, tells us detailed information about user, IP address, what they're doing, whether they're doing voice, video, or desktop sharing, how much bandwidth they need. And then we apply policy via QoS that says apply action, remark the QoS layer 3 DSCP code point in the packet. And now via OpenFlow, on ingress from the PC, the first little hop, we can't change what the PC is doing. But as soon as it hits that first switch, through the rest of the network, it's now marked as EF. And your WAN routers here, it could either be a WAN router or it could be an Ethernet service you're getting. All you need from them is to allow them to say, EF is a guaranteed level of service with an SLA. AF41 is a guaranteed level of service with a slightly lower service level agreement. And now you've got a truly end-to-end solution for users with inside your enterprise. Any questions on the slide? Any people have any comments or questions related to this? And similar, like I was talking about, some of the other actions we can do is the controller, like I said, can use this to, on a new flow, do the security inspection on a new flow. We can, at this point, mirror that traffic. So there's a lot of powerful things we can start doing by having, higher level business applications or APIs talking to the controller and then providing that level of functionality to the network switches. Another aspect of the API that we have is when things go wrong. How do you troubleshoot that? Because my belief is, now you've got a high-performance car, you've got a sports car with a big engine in there, but imagine not having any dials and gauges. How do you know what's going on, right? So it's important to have visibility on what the application performance is. And what we find is, Lync has an archiving server. Great tool, but organizationally, it's the application or the voice group that looks at that, while the network group is running the network. Okay? That's why you got a lot of finger pointing. The network's slow, right? Network guy goes, no. Something's wrong with the server. Or it might be the endpoint client. A lot of finger points going on. With the API now, at the end of the call, every Lync endpoint collects QE metrics, sends them to the archiving server, and then we get another API call at the end that now the networking engineer has visibility on what the call quality experience was for all the active calls. Okay. Now we also know exactly where those endpoints are. So if you have some bad calls, you know what 2 ports those are on, and you can start doing some tests. You can start running things like traceroute. You can start running things like ping. We also have something called our IMC, or Intelligent Management Center, which is a multi-vendor network management tool that allows you to correlate network traffic, and we're also adding this API to that platform because this Lync SDN app is useful and it has a dashboard to give you call quality. But if you truly want to do some detailed network monitoring, including for legacy network, that tool is ideal to let you diagnose what's going on. So we're extending that API both for hybrid SDN environments, and we're using this API for network management of existing legacy or non-SDN networks or hybrid networks as well. And it'll let you get detailed call quality. And we have additional modules that called NQA, which is similar to what Cisco does with SLA. They got IPSLA, which allows you to do some synthetic tests. So you can have certain routers pinging other routers periodically for the sites that you've identified have some call quality issues. And now you can check to see, is my service provider, is my network up to snuff? I'm paying for this SLA. Am I really getting that SLA that I thought I'm getting? So these tools let you, get visibility and let you help troubleshoot this. And then going forward, what we're doing is, as the next phase, I'm working closely with Microsoft to say, what are some additional things we can do? Okay. One of the biggest problems I hear in Lync environments, QoS is the biggest problem on audio quality issues, but the next biggest problem I hear is people have been told, I need to do CAC. And the reason you need to do CAC is the way voice and video works is, let's say you have a WAN link that can support 10 calls. Okay? You let 10 calls in. Everything's good. You've got your SLA set up to support that much bandwidth. Let's say you got 10 calls at 30 kilobits. You have an SLA that says, I'm going to have 300 kilobits of good quality over this link. If you bring up that 11th or 12th call, it's not the 11th or 12th call that goes bad. Every call goes bad. Okay? That's not what you wanted to do. So you've gone to the trouble to configuring QoS, but on occasional days when your network traffic, your voice traffic is higher than you expect, you're going to have an audio quality issue. So people understand why CAC is important. The problem, it's so difficult. The vast majority of customers I've run into simply threw their heads up and go, you know what? Screw it. And it's not just a Lync problem, it's a Cisco Call Managers and a Avaya problem as well. And the reason is it's programmed in the application. You program these rules in the application that says, what are my branch sites? How much WAN capacity do I have between there? And this is how much bandwidth I allow it to do. The day you set it up, it's already obsolete. Because if the networking group adds another WAN link or has a WAN that has some kind of dynamic varying capacity, it's already not able to do its job. Or worse yet, a common problem I've run into a large accounting firm, one of the largest accounting firms, is they're still running Call Manager and they're transitioning over Lync. And they expect this to be, say, a 2 or 3 year migration. So he goes, what CAC value do I give Lync today when I think it's only 10% of my traffic volume, but then over time it's going to be 100% of my traffic volume of voice? I don't know what policy to do, and it's so hard to change it on a daily basis. So here's another example of what we can do to automate something. But I contend CAC is the last resort, not what you ought to be doing until other options have been exhausted. So prior to that, what we ought to be doing is having the API talk back to the application. So the API should say, this is what I want, and the network says, you know what, you're trying to do a high-def video call, and you're trying to take up 4 meg. We simply don't have 4 meg, but I'll allow you to do a compressed call. This is how much I'll give you. And now the application can know to configure the codec to do the right thing rather than trying to take all the available bandwidth. Now imagine what a network administrator can do. They can set up simple policies at the high level that says, inside my campuses, I got a lot of bandwidth. Run high def between video conferencing in the same site. But for certain sites, I want you to do compressed video. But let's say I'm in sites with very expensive WAN bandwidth. Say I've got satellite links or wireless links where I'm paying. So let's say we're in India or Africa. You might have a policy that do not allow video. Okay. This would be a policy that's fairly easy to configure for a network administrator. And now, once you've got an SD-enabled infrastructure, the network can start enforcing these very quickly. Now, that won't happen overnight, but we want to start happening. This customers to start running hybrid SDN environments and having that infrastructure in place, and that will enable these new kind of capabilities that today are simply not even possible. So now what we have is we have a network that's truly Lync aware and is enforcing trusted per session dynamic policies. The policies only get enforced applied at the beginning of the call, and at the end of the call we tear them down. So we're not even using up any hardware resources when there's no calls in place. The reason we're applying it at the access layer is to do very granular flow-based things. It's something that's somewhat new to the industry. And so if you're trying to do this at the core of the network, you might need thousands or hundreds of thousands of flows, and most switches don't have those size tables in the switches. But at the access layer, you've got a 24-port switch or 48-port switch. How many connections can users possibly initiate with Lync? I mean, it's a limited number. Most of our ASICs have on the order about 4,000 open flow rules, so there's no issues of exceeding that, and it's very unlikely that all 48 users are going to start up a video session or audio session. So on the access layer, this will scale, maybe even at the distribution layer. But as you get higher in the network, we're going to have to innovate and create much more capable ASICs, and we are working on that. But in the past, nobody needed that benefit. So I think what we're seeing is the application in SDN will enable new functionality and unlock capabilities in your hardware. So in summary, AutoQS for Lync is secure, and this is focused on a hybrid model. So the question I commonly get is, how do I get to, from here to there? I have few people arguing. They said, this makes sense. This is great. But I don't have these kind of switches. This will take years to deploy. This is theoretical stuff. Well, the reality is we've been shipping OpenFlow enabled switches for quite some time. We have over 50 models of switches that are OpenFlow enabled today. We've got over 25 million ports deployed. When we started shipping these switches, we didn't even know they could do OpenFlow, and we've added it after the fact as a software upgrade. So there's already a significant portion of customers out there, or Lync customers, that have OpenFlow enabled, especially at the access layer, that can start taking advantage of this today. So we're already doing beta tests with customers with this solution. If you got a question, come up to the...
Well, you just answered the question, basically, but I just wanted to understand, you actually are setting this up for customers.
We're in beta right now. Yes. And I've got another slide to highlight this. But yeah, we have 25 million ports already deployed. Over 15 million of those are in the campus and branch environment. And our commitment is the vast majority of HP networking products will be OpenFlow enabled. We've already announced that our WAN routers will be OpenFlow enabled. Same thing with our wireless portfolio. But we want to learn to walk before we run and demonstrate people how to do this. So the point being is if you're getting ready to do a network access layer upgrade, and what we find is most VoIP, most Lync deployment needs some level of network refresh. Okay, is when we do the network assessment, there'll always be a portion of the network, and often it's the access layer that's, hasn't been upgraded the longest period of time, and that's the part that often needs upgrading for additional security function, additional QoS functionality, additional PoE functionality, because while IP phones aren't the future, they're not dead yet, and wireless access point with mobility, people need PoE to drive those. So what we say is, why not buy network infrastructure that's more capable from a performance standpoint than the competition, a better ROI, easier to use today, and even if you're not ready to do SDN, has that built in. So get an SDN-ready network infrastructure. Okay. In the campus layer, the expectation these days, it used to be 2 or 3 years was common for a refresh. Nowadays, it's 7 to 10 years is this expectation. And if you ask a customer, if you talk to customers that say, are you willing to put your head in the sand and bet that this technology isn't going anywhere over the next 7 years? I've yet to see a single customer say, I'm willing to throw money out the table and I don't think this technology makes sense. Okay. Virtually every major networking vendor has jumped on board while we've been driving around SDN and together with Microsoft to go, wow, this is compelling, and we want to do similar types of solutions. But I think we've got a significant lead in terms of that, in terms of innovation and technology. The next phase, and this is the part we're really entering right now, and what you asked is, where's the next phase? The next phase is really about a mixed hybrid SDN model. This allows you to have what I call the application-directed networking, the difference between guessing and knowing. It allows you to do it in reduced complexity. So now we're automating something that was very, very tedious and complex, and it's really a non-disruptive model. Because the network administrators, they like to control things, and they're afraid for you to fully automate things. We're not changing the routing. We're not changing how the packets are going. We're changing the QoS on the packet. If things go wrong with this application, it's the same as it was today. Right? In most environments, in many environments, I've seen customers simply not turn on QoS for the soft phone because it was simply too hard. And as you start going to BYOD, most BYOD devices don't even have any mechanisms in the OS to enable QoS. And even if they did, I guarantee you, if application developers figure out, all of a sudden that free app you can download is going to run at EF priority. So there's, in the wireless and BYOD world, you will not want to honor or trust the endpoint. You will want the network to enforce those policies. And then, over time, we'll start running to kind of a native SDN model. It won't be end-to-end SDN, but we'll have domains of SDN. You might have, certain branch sites, certain campuses will run a full SDN domain, but we will then still run routing protocols between that domain and the outside world, or between different domains. And at that point, it'll be important for us to start federating between SDN domains to automate functionality and do things like bandwidth brokering and things between domains. Carriers are extremely excited about that, but we first need to build the infrastructure, get enterprises running in a hybrid model, and areas running kind of in the pure native SDN domain. Within the data center, we're already seeing many larger data center providers are running pure SDN inside their domain, but now they're still running that outside. But what we want to do is drive that same model that these larger larger cloud providers have seen the huge benefit. We're trying to bring that to the campus and branch and down into the mid-market. So from an end-to-end SDN domain, it's like I highlighted, there's a lot of different people doing things that are doing SDN. And you'll hear a lot of pissing matches out there where people are saying, it's all about the virtual overlay, the underlay doesn't matter. Or there's people that say the underlay is the only thing that matters. Some people say the controller is the only thing that matters. We believe it's a complete end-to-end ecosystem. And I recommend working with vendors that have a comprehensive strategy and vision. Nobody has all the pieces there today, but work with vendors that have a comprehensive vision and that can get these types of solutions working. We believe that the overlay is nice. So in the data center where we're using the overlay to do vMotion and moving servers from one end to the other, that's compelling and useful. But if you can't automate the network underneath it, if you can't provide that, you have no bandwidth guarantees. And then when there's something wrong with the network underneath it, the overlay doesn't work. So an overlay that's just a virtual, which I highlighted over here, this V represents the virtual SDN. If that doesn't talk to or interact with a physical underlay, you really haven't solved anything. You've automated some things that were hard, but to truly have a true SDN solution, it needs to comprehend both the virtual switches, the physical switches, the controller, and the APIs to the applications. So where are we with SDN today? So I want to highlight, I think we've got one of the most compelling and comprehensive stories in the industry on software-defined networking. At the bottom here, we've got, from the infrastructure standpoint, we've got 50 miles of switches already that support SDN. We've got over 25 million ports deployed, and we're increasing that number over time. We've announced that our wireless and our routers will support SDN. The SDN controller, the piece in the middle, we shipped that last summer, so that's already shipping and deployed in customer environments. We have an API and an SDK that we've developed so that partners, integrators can start writing custom apps to do specific things and learning how this works, because we believe an SDK and API ecosystem will drive adoption of that. And we're working on a number of very compelling use cases and services that we're providing across campus, branch, data center, service provider to really drive that vision of what SDN can provide. So we've got that Lync application that we're in beta right now. We've got the Sentinel application, which is this IDS IPS. We're running that. HPO is running that in their network. We've got some school districts that are running that. And, for example, they found a very interesting use case that we never envisioned using it for. But they found that during classrooms time, kids were getting distracted. They just weren't paying attention to the classes. And they were trying to figure out what was going on. So they looked at the network traffic. Facebook was the predominant application taking up Facebook, Instagram, all these other things. So they said, well, we don't like to block traffic, but during classroom hours, we're going to use this policy to restrict traffic of Facebook and some of these other services during classroom hours, but outside of classroom hours, we're going to allow it again. So they used this as a very dynamic policy to do this automated, and seemed to be pretty effective, and they're showing that kids are paying attention more. So here's some examples of these kind of applications we're going to try to drive across the ecosystem. In addition to that, we believe that design, implementation, and services are important. So we have some educational services. We have some consulting services that we can provide to help educate people and customers on what SDN means and how do I start with SDN and roll that out. Any questions on any of that? Yes?
Do you have a list somewhere of these switch models that have it so that people can look up their switch models?
Yeah, very good question. All our switches on HP networking, in our data sheets, we list which models support OpenFlow, and we even list what version of OpenFlow we list. Some of the competitors basically say OpenFlow, but that, does that mean you support one feature? Does that mean you support lots of features? Which extensions do you support? So we really support a broad spectrum of it, and we're trying to provide very consistent functionality across our entire product line. There may be certain family of switches that can't support some functionality because of ASIC limitations, or table sizes might be different, but for the most part, we want to have that same functionality across our product line. But good question. So from a software-defined networking service, this is an example. I'm not going to go through all of them, but these are kind of the network services we are providing for helping people come up to speed on SDN strategy, SDN design services, even doing things like, what is my network like? Where would I need to upgrade my network? So we're trying to provide some educational and implementation services around that. So like I said, the quality of the user experience is only the quality of the network. So what I focus on here was primarily around SDN, but I did want to put in one kind of marketing slide to kind of highlight that it's not just around SDN. We have our, HP networking is Lync qualified. It's UCOIP certified. We were one of the first vendors. I think we were the first vendor to have our switching products qualified in the UCOIP. We've got IP phones. We've got Knowledge Worker. We've got the basic desk phone models for hot desking and stuff. So we have HP IP phones. Many people aren't aware of that. Good quality phones. We have our WAN routers that are also function as enhanced gateways. So they're Lync 2010 and Lync 2013 qualified. So they can work as an enhanced media gateway to bridge that gap to the legacy PSTN and branch environments. But in addition to that, we have an SBA module that you could put in there. So you can take this WAN router, which is a very competitive product compared to the competition, but now enabled to be a full SBA for both 2010 and 2013. Okay. This is one of our fastest growing product lines, is our WAN routers. In China, we have over 50% market share with that. It's growing very strongly in EMEA, Latin America, and we're growing certifications with carriers as well. So we believe that very compelling platform. Today, you could start using it as an enhanced gateway, because most people, when they're doing a Lync migration, you don't want to couple a WAN upgrade with a gateway or SBA upgrade, so you could start using it as an appliance. It's very cost-effective and competitive from that standpoint, but now you've got something that can replace a WAN router if that project comes up. And then we've got our Wi-Fi portfolio. We were just recently, a couple months ago, we're now Lync qualified, UCOIP qualified for a Lync mobility solution. And we've got our SDN application, which is in POC. In addition to that, our network management platform, our IMC Intelligent Management Console, will also support Lync diagnostics and device inventory for Lync endpoints. Any questions on any of that? We believe Lync is a very compelling story. We're going to continue focusing, driving more innovation in the network, but at the same time, we realize that customers are running other telephony solutions out there as well and need to support that. So we've done extensive support and are the leading multi-vendor provider for UC and IP telephony across the ecosystem. We work closely to validate and qualify our solutions in a multi-vendor environment, including some Cisco legacy environments. So if you've got a customer that has legacy CDP phones, if they've got pre-standard Cisco phones, we do support those on our switches, and we've got many customers running that because they wanted to do a migration. They needed to upgrade the networking, but didn't necessarily want to throw out those phones today. They want to do, say, a 2 or 3 year migration of that. And wanted to highlight some of the customer wins we have. We got a growing number of large customer wins, and from a market share, we're bigger than the next 6 networking vendors combined. So we believe we've got a really good story around Lync. We're really resonating with customers, and we're growing our portfolio rapidly. So as the next steps, recommend do stop by the HP booth, learn a little bit more about my technology, of what we can provide. We do a lot of business through our channels, but we also have technology services here. So if you have a large project for a large company that you want integration services, we have that as well. Learn about how HP plus Lync can deliver you true ROI savings today, but more importantly, how to future-proof your investments and start on that SDN journey either today or in the near term. And any questions on that?
Did you want to mention, or can you mention, HP's internal deployment of Lync?
Sure. Yeah, so HPIT is one of the largest. We're the largest Lync deployment, and yesterday we released our case study. So it's a pretty interesting case study that you might want to read of how an enterprise went to supporting over 400,000 users for Lync for IM and presence, PC-to-PC calling, conference calling, and we're now somewhere between around past, I think, 80,000 enterprise voice deployments, and are still ramping that up. And we're over 100. Thank you. We're now over 100,000 and growing. And we're ramping up that pretty quickly. We're using our, all HP networking switches. Most of them are these open flow switches we talked about. We're using our MSR routers. We're using our gateways. We're using our SBAs in that environment. We're using IMC platform in that environment. And it's really a good case study to show to customers how Lync is ready for prime time for very, very large customers, how you get some compelling cost savings. One of the great points in there is we talk about how when you start a conference call, we save on average, we save 45 seconds for starting a conference call. And if you multiply that by, on average, we have 100,000 users a week using this. Okay, think of that time saving on that alone, not including the ROI savings and all these other benefits. So these savings are really compelling. This is a great case study to show to your customers and partners on ways of what we've done to do this over phase migration, systematically migrating our infrastructure. I posted it on my LinkedIn profile, and I saw it on UC Strategies. So if you're familiar with the UC Strategies website, it was posted on there yesterday. I assume it's somewhere on the HP website. I just haven't seen it yet. It only came out yesterday. Yes?
What's the licensing model for this product?
Why don't you stop by our booth? We can talk about that in more detail. We're trying to be very cost effective. I'm an R&D guy. I'm a technologist, so I don't like to talk pricing. I don't like to get into the aspect of things. But very, very compelling pricing. OpenFlow, we don't charge anything for the OpenFlow functionality. Typically, if a customer has our switches, they likely will need a new firmware upgrade. We don't charge anything for that firmware upgrade on most of our products. We don't charge anything more for the OpenFlow functionality. But the controller has some licensing costs on there.
But there's not like a per port on a device?
No, there's not a charge per switch, but the controller will have some licensing involved with that based on the number of users that you're going to be running. The product's not shipping yet. Okay, so it's not a shipping product. It hasn't been announced yet. This is something that's under development. So I can't really talk about pricing anyway. Yes?
So your Lync voice deployment case study is also SDN?
Not yet. That's not SDN running yet. Because remember, we started this in the OCS days, and we're upgrading. But SDN we've been working closely with our HPIT to design SDN in a model that fits into their needs. And as part of the beta, HPIT is something we're looking at as well, using that. But very good question on that. I do have a couple of slides I need to show you that they requested me to provide you. You've seen that one. Do submit the reviews. Okay, I guess you can win some prizes or something if you submit the reviews. But they really want you to submit reviews to help with content for next year. Was this the right level of content? Did I go into too much detail? Did I not go into enough detail? Is this important for what you see? What would you like to see going forward? So do please submit the reviews. I also want to let you know I have another SDN speaking session. That one is not going to go in as much detail on the networking side. It's with Microsoft, so I'm a speaking session with Pascal. I think it's at around 4-ish time frame. Network 302. And that one's going to focus a little bit more on the API. We're going to talk about what the API provides and some of that capability as well. So there's maybe about a 20-30% overlap between that, but that may be interesting for you as well if you see SDN as an interesting technology. Any other questions? Well, thank you. Hope you found this information useful. I believe we're really, like I said, we're at a point, I think, in the network industry when we're going to look back that this is fundamentally changing, how networking operates from box-to-box basis to more of kind of a system, automated and orchestrated environment.